This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. At higher level, many of these questions involving sine, cos and tan and Pythagoras' theorem are usually made harder by introducing some sort of real-life scenario. So in our example here, we're going to be introducing compass directions to make the question a little bit more difficult. So the question reads, Jerry is out playing golf. As he approaches the 9th tee, his friend tells him that the hole is 310 meters from the tee at point A to the hole at point C. On the first stroke, the ball travels a distance of 225 meters in the direction north 40 degrees east. Jerry then takes his second shot and the ball travels in the direction south 50 degrees east and rolls onto the green and into the hole. Our questions are 1. How far did Jerry hit the ball on his second shot to the nearest meter? And 2. To find the angle ACB to the nearest degree. Okay, so to answer this question, what we're going to need to ask first is what information are we given in the question? So if we look first, we're told that the hole is 310 meters from the tee to the hole. We're told that on his first stroke, Jerry hits a distance of 225 meters in the direction north 40 degrees east. And then in the second shot, the ball travels in the direction south 50 degrees east. So from this information, we're going to have to try and create a diagram for ourselves to see what way we can go about answering this question. So we'll start by just drawing in our point A, and at point A we know that he hits the ball at an angle north 40 degrees east. So this angle here being 40 degrees. And we know it goes a distance of 225 meters. To a point up here, let's call it point B. And again, our compass directions. We then know that he hits it in the direction south 50 degrees east. So that's down here to the point C. And we were originally told that from A to C is 310 meters. So from A all the way to C is 310 meters. And this angle up here is 50 degrees. Now you might remember from your geometry courses in the junior certificate that if you have two parallel lines, like we do here and here, then if you draw any line between them, such as the one we drew from A to B, then you can use alternate angles to write that since this angle here is 40 degrees, that means this angle here must also be 40 degrees. Which means that if we look at the angle at B, this angle here, it's equal to 40 degrees plus 50 degrees, which is 90 degrees. Which means that the angle at point B is actually a right angle. Okay, so all I've done here is to redraw what I had above just a little bit neater with our same triangle A, B, C, and all of the same distances we had before, 310 meters, 225 meters, and our same right angle at the point B. So now that we know this, we can just go on with our questions and use our rules from right angle triangles to work them out. So the first thing we were asked to work out is how far did Jerry hit the ball on his second shot. So what we're asked to work out there is this distance here from B to C, and we'll call that x. So all we're going to use is our Pythagoras' theorem. Since we know the other two sides, the only thing we need to keep in mind is which side we label as h, remembering that it has to be the side opposite our right angle. So the 310 meters becomes our h, and our other two sides are our O and A. So filling our numbers in and working them out and getting x squared just to one side, we eventually come to the answer that x is 231 meters. The next question we're asked is to figure out the angle ACB. So if we look up at our diagram, we see that the angle ACB is this angle here. This is our angle ACB. Now, since we know all of our sides now, we can use any of the sine, cos, or tan rules. We just have to keep in mind what we label as H, O, and A. So in my answer, I'm just going to use the sine rule. So I'm going to use sine of our angle, call it theta, is equal to O over H. So then the next question we have to ask is what is our O and what is our H? The O in my case is going to be the angle opposite ACB, which is our 225 meters, which I have here. And our H, as always, is our 310 meters here. So in order to get what the angle ACB is, all we need to do is the sine inverse to both sides of this equation, and we eventually find to the nearest degree that the angle ACB is 47 degrees. And that's the end of that question.